So we have a parallel AC parallel circuit. We're going to find Z total, I total, I1, IL1, IR1. All right, so what's the first thing we always do? Make sure we're in phasor, because we know we got to be in phasor to solve. Well, I'm in phasor. Okay, 220 volts and angle 0. What's the next thing I do? Get my X of C and X of L. Well, I gave them to you in ohms, which means I gave you what? X of C and X of L. So all I got to do is go by and put angles on everything. So capacitors have an angle of?
Minus 90.
Negative 90. Inductors?
Positive 90.
Positive 90. And resistors?
0.
0. So you're right. I didn't need the 60 ohms. I just gave it to you. Doesn't mean everything I give you, you're going to need. Okay. Now I find my Z total. So what do we get for Z total?
33 ohm.
I got 15 ohms with an angle of 36.870.
Uh-oh. I think, anybody get anything different?
Yeah, I got 7.682 ohms at an angle of minus 50.194.
That's what I had too.
7.682 ohms at an angle of negative 50.194. You guys remember when we do parallel, I must take
Oh, snap.
6 ohms at an angle of negative 90. Everything has to be in parentheses before I shift reciprocal.
Yep, totally forgot to do that.
If not, I'm only going to shift reciprocal my angle, and then I'm going to get everything wrong. So make sure when we're in parallel, I got to put it all in parentheses and then shift reciprocal. Then I can add my next one, all in parentheses, shift reciprocal. Then I can add my next one. The only one you guys don't have to do that for is your resistor. And why is that?
Angle 0.
Exactly. You don't even have to put the angle 0 on there if you don't want to. If you don't put any angle on it, it's going to assume it's at an angle 0. So the resistor you don't have to put. If you get in the practice of doing it with the resistors as well, then you'll start remembering, I got to put everything in parentheses. Everything's got to be in parentheses. So what do we get for I total? Somebody give it to me.
28.638 at an angle of 50.194.
28.638 what?
Oh, amps.
Amps. At an angle of 50.194.
Yep.
I see one. I'll give you that one. 36.667 amps at an angle of 90 degrees. IL1. You got IL1.
I got lost here.
Uh-oh. I got her lost. 14.667 amps at an angle of negative 90 degrees. And IC or IR1. 18.333 amps.
Oh.
How do I know they're right? I add all three of them up, and they better equal my I total. And when I added them all up, I got 28.6374 amps at an angle of 50.194. Pretty close to 28.638 at an angle. Don't worry, I am recording this, so you'll be able to go back and see the answers. So let me ask you guys a question. What if I gave you this circuit and said, Could you find that for me?
Got to go the other way. It'll just be divided.
I got it. What kind of equation would I use to find C? Well, what equation do I know that has C in it, in AC? X of C, right? 1 over 2 pi FC. So if I want to find C, I got to multiply both sides by C and divide both sides by X of C. So I get C equals 2 pi F X of C, which would be 1 over 2 pi times, now I need my frequency, 60 hertz times 6 ohms. And if I figure that all out, I should get 442.097 microfarads. So that's the value of this capacitor. This one, I do the same way. What do I know? X of L, and it equals 2 pi FL, right? Well, if I want L, I just divide by 2 pi. X of L divided by 2 pi F. So I got 15 ohms divided by 2 pi times 60 hertz. And if I do that, I get 39.789 millihenries. So I could ask you for the value of the capacitor or the inductor if I give you X of C, but I have to give you the frequency. Because if I don't give you the frequency, you can't figure it out. Or it would have to give you omega. Okay? I just use the equations that I know and just manipulate them around so that way I can find what I'm looking for. Will I ask you that on the test? Probably not. I'll probably just ask you to solve the equations. So, all right, so we know how to do series, obviously. We did the homework. Seems like you guys know how to do parallel, just some people forgot to put the parentheses around everything, but you were on the right track. Just got to remember to put parentheses around everything. So let's move on to series arrows. So let's do a circuit like this. Marker's fine. So I got a what? An AC series parallel circuit. No different than when we did a DC parallel circuit, except for our steps. We're going to make sure we're in phasor voltage. We are. Find X of C and X of L. Already gave them to you. I'm just going to put angles on everything. I know my resistors have an angle of 0. My inductors are 90. And my capacitors are negative 90. Now I'm going to do the same thing. I'm going to go farthest away from my source if I can, which I can. These two are in
Series.
series. So in series, pretty easy. I'm just going to add them up. 200 ohms oops, at an angle of 0 plus 100 ohms at an angle of negative 90. When I punch that in my calculator, I get 223.607 at an angle of negative 26.565. And I want to circle this because that's what I care about. Okay. I'm going to redraw it. Where am I going to put this? In parallel with my inductor. Okay. So I'm going to redraw it. But this time, when I put it in parallel before, I did what? I just drew a resistor, right?
Yes.
Well, now that I'm in parallel, or I mean, I'm in AC, I don't have the same components here. So I'm just going to put it in a box. That way I know I've got different components in here. Okay. 223.607 ohms at an angle of negative 26.575. So anytime I'm adding different components together and I'm doing it or in parallel, I'm doing it in AC, I'm going to put it in a box rather than put a resistor because I don't want to think that it's a resistor or it's a capacitor. I know I have multiple components together. Okay. So this one was 500 ohms. 0, 300 ohms at an angle of 90. Now I do these two in parallel. So I got 300 ohms at an angle of 90 in parallel with 223.607 ohms at an angle of negative 26.575. I know I'm running out of space.
Is it 575 or 565?
Oh, 565. I can't copy from one to the other. 565.
Don't worry, we're all having that same problem.
See, it doesn't happen to just you guys. And when I punch that in my calculator, making sure I put everything in parentheses before I push my shift reciprocal, I get 237.167 ohms at an angle of 18.434. And I'm going to circle that one.
I did that wrong.
Make sure you put everything in parentheses
I multiply, isn't it?
before. Yeah, don't multiply. In parentheses, shift reciprocal plus. And then I'm going to redraw it again, and I'm going to put this box in series with my 500.
You do open parentheses 300, angle 90,
Close parentheses, shift reciprocal. That way it will shift reciprocal everything inside your parentheses.
and then it's plus.
And then plus, just like we always do. It's always plus the next one, shift reciprocal. But I have to put all this inside parentheses. So open parentheses 223.607 at an angle of negative 26.565. Close my parentheses, shift reciprocal. Then I hit equals, and then I hit shift reciprocal again. I don't have to worry about parentheses now because it's going to shift reciprocal my whole answer.
You got 237.67
at an angle of 18.434. Angle. So then I'm going to put this in a box in series with my 500. I don't have room to redraw it here. So I'd wind up with a simple series circuit that looks like this. So this is 10 volts, angle 0. This is 500 ohms, angle 0. And this was 237.167 ohms at an angle of 18.434. So I'm left with a simple series circuit like that. Now I can find my Z total. It's a series circuit. I just add them together. So Z total, I got 728.866 ohms at an angle of 5.906. And then I can get my I total, and I get my voltage drops on each one of these. And then I look back. Well, what did I circle? I circled 237. How did I find it? With these in parallel. So what do I bring back to both of these? Whatever my voltage drop is here, which just happens to be 3.254 volts at an angle of 12.528. So that voltage drop comes back to there and to there, because those two were in parallel, so they're going to have the same voltage drop. Now I figure out my current here and here. When I add these two up, they got to equal my I total, because that's where they came from. They came from here, and that's going to have my I total going through it. So I'll get these two currents. When I get this current, I found this by these two in series. So that current is going to come back here, and it goes to both this resistor and that capacitor. And then I can get my voltage drops across both my resistor here and my capacitor. So now I'm going to have my voltage drop and my current for here. Here I got my voltage drops here. That gave me my voltage drop and my current for this inductor. When I bring this current back and I find the voltage drops, now I got the voltage and the current for that resistor and that capacitor. Just like we did in DC, it's a little more involved now because we got angles. So if I get them all, this current came out to be 10.847 milliamps at an angle of negative 77.472. So that's the current through my inductor. All right. This current was my I total, which came out to 13.720 milliamps at an angle of negative 5.906. So that was also my I total. Makes sense, right? Because I is coming up this way. It's going to go through, everything's going to go through my resistor. Then this voltage drop we know was 3.254 volts at an angle of 12.528. This voltage drop, when I got it back here, I should have got 6.86 volts at an angle of negative 5.906. You guys can go back and figure all these out then, just to make sure you're right. Because I'm going to give you another one then to do on your own. Not quite as difficult. We'll start out easy. When I get the current here, that's going to come back here. Came out to 14.553 milliamps at an angle of 39.093. Then I can use this current, multiply it by both of my Z's to get my voltage drops. And And up here I get 2.911 volts at an angle of 39.093. Bingo. And here I got 1.455 volts at an angle of negative 50.907. When I add these two voltages up, they got to equal my voltage here, which is 3.254 volts at an angle of 12.528. Everybody get it? Kind of see what we're doing? Same thing we did in DC. It's just now we got angles and we're going to put everything in boxes because we're going to have multiple components together. We're not just going to have all resistors together. So I can't just say, well, hey, I just made another resistor. I'm going to have, here I'm adding a resistor and a capacitor together. So I'm going to put it in a box. Everybody good? See what we're doing. All right. I'm going to give you one that's a little bit easier to start you out, just to see how we're doing. If we're doing good, we'll do one a little bit more difficult. Remember what I said, if you can do my difficult ones in class, you'll never have a problem on the test. I'm always going to give you more difficult ones in class than what I'll give you on the test. Because if you can do the difficult ones, the easy ones should be cake. So let's try this one. I'm going to let you guys try this one on your own.
Yeah, whatever. Doesn't matter. What?
Yeah, I puked it up already. Okay, wrong sheet. So I want you guys to go ahead and do this one and get me everything, current and the voltage for each of my components. I'll give you guys a few minutes to go ahead and do this, and then we'll pick it back up. And this one was 12. Hey, I'm going to get another marker. 12 ohms at an angle of 90. Well, what do I have now? I got a parallel circuit. So I know that this voltage drop is 60 volts at an angle 0. And this is 60 volts at an angle 0. So I want my I total, so I got to find Z total first. This one in parallel with that. So 12 ohms at an angle of 90 in parentheses, shift reciprocal, plus 15.060 ohms at an angle negative 52.826. All that in parentheses, shift reciprocal, equals, shift reciprocal equals, and I should get 19.860 ohms at an angle of 37.173. Make sure we put them in parentheses because they're in parallel, so I got to do the shift reciprocal.
I did that,
Now,
but I didn't get that answer. I got 50.353. Well, actually, I got 0.050, 0.050
12
No,
ohms
numbers.
at an angle 90, shift reciprocal, plus 15.060 at an angle of negative 52.826, close my parentheses, shift reciprocal equals shift reciprocal. I got 19.860 at an angle 37.173.
Oh, I'm not saying it's wrong. I'm just saying I didn't get that. Twice now.
Should look just like that when you put it into your calculator. 12 ohms at an angle 90, all in parentheses, shift reciprocal, plus, open my parentheses, 15.060 at an angle negative 52. I'd have to scroll over so you can see it. Close my parentheses, shift reciprocal, and you should get that answer right there. 0.050. Ah, that's why you didn't shift reciprocal again, did you? Because you said you had 50 milliohms, right?
Yep.
Yeah, you got to shift reciprocal your answer then. Because remember, it's 1 over 1 over. And when I shift reciprocal that whole answer, I get 19.859737 at an angle of 37.173188888. You forgot this step right here, where I shift reciprocal my answer after I added the two together.
Yeah. All right. I guess I've been doing them all wrong.
Because remember, how do I find it? 1 over R1 plus 1 over C1 plus however many I have, right? So when I put everything in parentheses and shift reciprocal, I'm just doing this part. And then I'm just doing this part, adding them together. Once I get that answer, I'm still 1 over that answer. I got to shift reciprocal one more time. Just like we did in DC, we did the same thing. It was shift reciprocal plus whatever shift reciprocal plus whatever shift reciprocal equals shift reciprocal. And that was our answer. So now I can get I total. Why do I want I total? Because when I get the current here and the current here, I need to add them together to make sure they come up to my I total. Because if they don't, then I did something wrong. And I don't want to continue on until I make sure this circuit is correct. So I total. And when I did it, 60 volts divided by that, I got 3.021 amps at an angle of negative 37.173. That's my I total. Now I can go back and get my currents here, just voltage divided by impedance, voltage divided by impedance. This one here is pretty easy. This one's 5 amps at an angle of negative 90. And I know sometimes you can't see it very good on this board. And same thing here, 60 divided by this, you should get 3.984 amps at an angle of 52.826. That's my current here. Then I'm going to add those two currents together, make sure I get I total. If I do, I'm going to take this current back up here, right in between here, 3.984 amps at an angle of 52.826. I'm going to put it right in between them because I know it goes where? It goes to both of these because they're in series. Now I can get my voltage drop. Simply take the current times the impedance, current times the impedance. Here I get 36.254 volts at an angle of 52.826, and that's a 3 and a 6. And for this one, 47.808 at an angle of negative 37.174. Let's see if I can make that look like a 3. Bam. Then I add these two voltages up and they must equal what? Where they came from. Well, where did they come from? They came from this, which was here. So they got to equal 60 volts at an angle of 0. All right, so let's do this one together. We'll go step by step. Maybe this will help you guys out. First thing I'm going to do is I'm going to look at my voltage, make sure I'm in phasor. Bam, I am. So I'm good. Then I'm going to look and make sure I got my X of C and X of L, which I do because it's in ohms. So I'm going to go by and put angles on everything. Angle 0 for my resistors. Angle negative 90 for my capacitor. And an angle of 90 for my inductor. Okay. Now I'm going to say, okay, well, I got a series parallel circuit, so I want to start farthest away from the source. So if I start over here, well, what do I have? I've got these two in series, but I also notice I got these two in series too, right? So I'm going to do both of them at the same time. So what I'm going to do is I'm going to say 40 ohms at an angle of 0 plus 60 ohms at an angle of negative 90 equals something, and 80 ohms at an angle of 90 plus 20 ohms at an angle of 0 equals something. Because then when I get both of these, I'm just going to squish these two together, squish these two together, and I'm left with what? I'm going to be left with a parallel circuit. So when I figure this out and I put that in my calculator all nice and handy dandy, I should get 72.111 ohms at an angle of negative 56.310. And I'm going to circle that one because that's the one I'm worried about. And when I punch this one into my handy dandy little calculator, I'm just adding them together. I should get 82.462 ohms at an angle of 75.964. And I'm going to circle that one. And then I'm going to redraw my circuit. 5 volts at an angle of 30. Come up over. I got me a nice nifty little box because I know when I put those two together, they weren't the same components. Same here, they weren't the same components. So this one's 72.111 ohms at an angle of negative 56.310. And this one was 82.462 ohms at an angle of 75.964. Okay. Well, I know it's a parallel circuit, right? So I already know 5 volts at an angle of 30 is my voltage drop here, and 5 volts at an angle of 30 is my voltage drop here, because the voltage is constant in a parallel circuit. But I need to get my Z total so I can get my I total, so when I get these currents, I can make sure they're right. So Z total, what I'm going to do is I'm going to punch it in the calculator. Open parentheses, because they're in parallel, 72.111 ohms at an angle of negative 56.310. Close my parentheses, shift reciprocal, plus, open my parentheses, 82.462 ohms at an angle of 75.964, close parentheses, shift reciprocal, equals, shift reciprocal equals. Okay, everybody see that? I'm going to hit equals, shift reciprocal equals. When I do that, you should get 94.021 ohms at an angle of 1.218. So everybody do that and make sure you get Z total 94.021 ohms at an angle of 1.218. We're not going to move on until everybody tells me they got that for Z total.
I'm good.
If they don't have it, well, that's going to be on them. So now I can find my I total because I got Z total. So I total, just E total divided by Z total gives me I total. When you do that, you should get 53.180 milliamps at an angle of 28.782. So everybody get your I total. Let me know if that's what you got.
I got 0.053 milliamps. I didn't move the decimal because I just didn't see the need to.
But if you put
So
0.053, it's
it'd
not
be amps.
milliamps. It would just
It's
be amps.
just amps.
Okay. But I want you to move it so you get more numbers. Because 0.053 is not going to be as accurate as 53.18. Now that I got my I total, I go back, voltage divided by impedance, voltage divided by impedance, and I'm going to get both my currents here. This one, 69.338 milliamps at an angle of 86.310. This one, 60.634 milliamps at an angle negative 45.964. Once I get them, I'm going to add these two together and make sure I get that. If I don't, I did something wrong and I'm not going to go any further yet.
I did something wrong.
Did you get these two answers?
No.
5 at an angle 30 divided by this one. 5 at an angle 30 divided by that one.
I skipped a step.
What step did you skip?
I'm not sure.
Did you forget to divide something? Because we already found I total was E total, 5 at an angle 30 divided by my Z total, 94.021. Now I'm just going to go back. I know the voltage is constant because they're in parallel. So I'm going to take the voltage divided by the impedance. The voltage divided by the impedance. Get my two currents. Once I get these two, I'm going to add them two up and make sure I get my I total. Because those two added together should give me my I total. So just divide 5 volts at an angle 30 by 72.111 and an angle negative 56.310. And you should get 69.338 milliamps at an angle 86.310.
Yeah, it's there.
Then do this one. Make sure you get this one. Make sure you get 60.634 milliamps at an angle negative 45.964. 5 volts at an angle 30 divided by 82.462 at an angle 75.964. Because you get these two, you're going to be good. So I checked these, made sure I got my I total. How did I find this 72.111? Well, I went up here. I found it by this 40 and the 60 in series. What's constant in a series circuit? Current. So what do I bring back? What's constant in a series circuit?
Current.
Current. So what do I bring back?
Current.
The current. So I bring this 69.338 back to both of these, and then I multiply my impedance times my current, my impedance times my current, and I get the voltage drops on these two. How did I find this 82.464? Oh, this 80 and this 20 in series. What's constant in the series circuit?
Current.
Current. So what do I bring back?
Current.
Current. The 60.634 milliamps comes back to both this 80 ohm inductor and this 20 ohm resistor. And then I can find the voltage drops on all four of these just simply by multiplying the impedance times the current, the impedance times the current, impedance times the current, impedance times the current. When I get both of the voltage drops here and I add them up, what must they equal? They must equal where they came from. Where did they come from? They came from this 82.464 ohms at an angle 75.964. What was my voltage drop here? 5 volts at an angle of 30. So when I add these two together, they got to give me 5 volts at an angle of 30. When I add these two voltage drops together, what do they got to equal? Where they came from. They came from here. What was my voltage drop? 5 volts at an angle of 30. So they got to equal 5 volts at an angle of 30. So when I did that, I got 2.774 volts at an angle of 86.310 for the 40 ohm resistor. I got
Too busy. I can't even
4.160 volts. Hold on, I'll tell you what it is again. At an angle of negative 3.69 volts here. Which one can't you read?
The drawing is just so cluttered. I can't. It's
I took
just
this current.
very, very busy.
See this current right here, 69 point. That current I found with these components, which I found by these two in series. So I took that current back here and I multiplied each one of these times the current to give me my voltage drop.
I know how you got it. It's just
Okay.
after it's all redrawn, It's no longer.
I know, because I don't have much.
decipherable.
Because I don't have much room here.
Yeah, well, I have the same
So-
problem on paper. I can't do one problem on one page. It's like
Then I'm
40.
gonna add these up, and I'll make sure I get 5 volts at an angle of 30. Bam, I'm good. Now I'm gonna come over here. I know this current came back here, so I'm gonna multiply each one of these by that current, and I should get 4.851 volts at an angle of 44.036 for my inductor, and 1.213 volts at an angle of negative 45.964 over my resistor. I'm going to add these two up, make sure I get 5 volts at an angle of 30. Bam, I do. I'm good. And I'm all done because I got my current and my voltage for each component in the system. Not too hard, right?
No, it's really simple. Just very, very cluttered. It's if you make one
It's
small
series
mistake,
parallel.
it's difficult to find it.
You know, that's how we did series parallel in DC. It was also very cluttered. So what I'm going to do is I'm actually going to give you guys a nice break. Okay.
Oh, good. I'm gonna go have a smoke.
Well, go ahead. Go have a smoke. Okay. So the last thing that we need to learn for this class is how to find C total. That's my total capacitance. So let's say I have a circuit like this, and I want to find my total capacitance. Okay. So I want to find my total capacitance. What I need to remember when I'm trying to find total capacitance. Capacitors in series act like resistors in parallel. So if they act like resistors in parallel, how would I find the total capacitance here?
Open parentheses.
1 over C1 plus 1 over C2 plus however many I have. So here I would put 3 exponent negative 6 shift reciprocal plus 3 exponent negative 6 shift reciprocal equals shift reciprocal equals, and I should get
1.5
1.5
micro.
microfarads. Or because they're in parallel, remember we learned in parallel, if they're the same, I can just put 3 microfarads divided by how many I have, which is 2, 1.5 microfarads. That's only if they're all the same. Okay. So that's how I'm going to find the total capacitance if the resistors are in parallel. Or I mean in series. If they're in series, they're going to act like resistors in parallel. So basically I'm going to shift reciprocal them. Okay. So let's try one on your own.
I was gonna say I got this one in case you're worried.
Okay, you got this? Let's see if you got it. So let's say I got
Let's see where you at.
So find C total. Jason, since you got this, you get it, you tell me what you got.
Holy crap. I got 8.194 microfarads.
Try again. Got the right numbers. You're just wrong in your units.
Well, the calculator says negative 0.6, which is micro, is it not?
I don't think your calculator should say -6. -6.
It does.
Mine does too.
Hang on, I'll take a picture and send you what my calculator display is.
Hold on. Maybe I wrote it down wrong. Let me check.
Nanofarads.
Nanofarads.
Did you get that?
Well, you told me microfarads, man. And you said that's what your calculator said.
That is what my calculator says. I just took a picture of it and sent it to you.
Oh, pico's -12. Yes.
I didn't say pico, I said micro.
It's getting big on the bottom, so.
Mine says 8.193586656 exponent -9. Did you put exponent
I
-12
put-
for pico?
Yes, I put -9.
Ah, and that's why.
That's why I said, you look at the picture I just sent you?
8.194 nanofarads. No, I did not. I heard it buzz, but I was punching it in my calculator. And yep, because you put 8200 exponent -9, that'll do it.
Oh, coffee down the wrong pipe.
So that's pretty simple, right?
Yeah,
Not hard.
just got to know your units.
Just got to know the units. You got to know which ones are -9, -12. So let's say we got this. What do you think C total is there?
The opposite of what it is in series.
Well, if capacitors in series act like resistors in parallel, guess what capacitors in parallel act like?
They're in series.
Oh, and how do we find R total in the series circuit?
Just
Add 'em up.
Just add them up. So capacitors in parallel act like resistors in series.
That's wonderful.
So we just add them up. And you should get that. 9.0082 microfarads. So let's try another one. I'll let you do this one on your own. This blue marker does work a little better, doesn't it? What's C total?
27 microfarads.
Oh my God, look at this guy. He's a freaking wizard.
We gotta do his ad.
27 microfarads. So if they're in parallel, we just add them up. If they're in series, we must do them like resistors are that are in parallel. Okay, so
I miss you.
what are you doing in my class?
I haven't seen you in forever. You don't call me no more.
Man, I've been busy.
Too busy for your friend? I feel like a redheaded stepchild.
All right, so find C total in this circuit. Remember what we learned. Capacitors in parallel act like resistors in series. Capacitors in series act like resistors in parallel. Don, we can chat here in a few minutes because I'm almost done.
Hey.
I'm about to send them on their merry way and make some copies of some homework and put in for them to do.
There's still that homework sheet in there.
Yeah, they've already
Should
done
be.
that. They've already done that. That just has peak to peak.
No, the capacitor homework. There's a sheet.
Oh, yeah. I'm going to put that in there for them to do too. Because I'm going to be nice and give them Thursday off, so that way. Remember, it's a what? Series parallel. So I start farthest away. What do I got?
3
These
microfarads.
two in 1 microfarad plus 2 microfarads equals 3 microfarads. So now I got a 3 microfarad here. What do I got? Those are all in series, so it's 3
Can I change my answer?
microfarads in parallel with 3 microfarads in parallel with 3 microfarads. And if I do that,
in parallel with
no, those 3 are in series. That is it.
what?
It gives me 1 microfarad. That 1 microfarad would go right here. And now I have 10 microfarad in parallel with 1 microfarad,
11.
which gives me 11 microfarads.
And now let's write one more time.
Only these 3 are in series because when I push them all together, they wind up with 2 points in common with that 10, which puts them in parallel with the 10. So my answer is 11 microfarads. You will have a problem like this on the test.
I don't understand why though. Like I mean,
What do you mean? These 2 are in parallel, right?
right? So those
So
2 took the place of the 1.
When I put these 2 here, this goes away.
Right. That's how I redrew it.
And
That's
this
3.
becomes a 3 microfarad.
And
Now
you've
this
got
one, this
4
one,
in-
and this one, no, because
I
this
see.
group together has 2 points in common with the 10. These 3 right here have this point and this point in common with the 10. So that means this group of 3 is in parallel with that 10, but I got to do these 3 in series first, which gives me a 1, which means these go away and this becomes a 1 microfarad and it's in parallel with my 10.
So
Just
it's
like
not,
when we,
it's not
right.
the same rules as in DC.
It is, because if these were all resistors, okay, just like when we were in DC, let's make them all resistors. 10 ohm. 3 ohm, 3 ohm, 3 ohm, okay? These 3 are in series, but they're in parallel with the 10. The only difference now is I'm going to add these up instead of act like they're in parallel.
I mean, I get what you're saying. Just, I guess I just don't remember it that way.
Yes,
But
because
that's all right.
this group has how many points in common with that 10? It has 2. So that whole group, once I put these all together, is in parallel with my 10. Same thing with the capacitors. Those 3, if they were capacitors, are in series. So I figure them out like resistors in parallel. And then that answer goes here in parallel with the 10. So then I would add them together. That's how I get my 11 microfarads. Don't worry, I'm going to give you some of these for homework too. So.